Hello everyone, I am Dr. Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about spectroscopy. Introduction to spectroscopy, classification of spectroscopic techniques, common types and their introductions, infrared spectroscopy, fundamental concept, vibrations in IR reasons and calculations of different vibration energy in terms of frequency. So what is spectroscopy? The study of interactions between radiations and matter as a functions of wavelength. Interaction with particles radiation or a response of materials to an alternative field or varying frequency. When a spectrum, a plot of the response as a functions of wavelength or more commonly frequency is referred to as a spectrum. You know friend, a spectrometer. What is a spectrometry? It is the measurement of these responses and an instrument which performs such measurement is a spectrometers or a spectrograph. Although these terms are more limited in use to the original field of optics from which the concept sprang. Spectroscopy is often used in physical and analytical chemistry for the identification of substances through the spectrum emitted from or absorbed by them. Spectroscopy is also heavily used in astronomy and remote sensing. Most of them, spectroscopy, a large telescope have the spectrometer, which are used either to measure the chemical composition and physical properties of astronomical objects or to measure their velocities from Doppler shift of their spectral lines. Now friends, classification of method. The types of spectroscopy depends on the physical quantity measured. Normally, the quantity that is measured is an intensity either of energy absorbed or produced. Most spectroscopic methods are differentiated as either atomic or molecular based on whether or not they apply to atoms or molecules. Along with that distinction, they can be classified on the nature of their interaction. Absorption spectroscopy. It uses the range of electromagnetic spectra in which a substance absorbs. This includes atomic absorption spectroscopy and various molecular techniques, such as infrared spectroscopy. In that region, the nuclear magnetic resonance spectroscopy in the radio regions. Emission spectroscopy. It uses the range of electromagnetic spectra in which a substance emits. The substance first must absorb energy, and this energy can be from a variety of sources, which determine the name of the subsequent emission, like luminescence, molecular luminescence, and technique includes a spectrofluorimeter. A scattering spectroscopy. It measures the amount of light that a substance is scattered at a certain wavelength, incidence angles and polarization angles. The scattering process is much faster than the absorption emission process. One of the most useful applications of light scattering spectroscopy is Raman Spectroscopy. Now friend, common types: fluorescence spectroscopy, Xray spectroscopy and crystallography, flame spectroscopy, atomic emission spectroscopy, atomic absorption spectroscopy, atomic fluorescence spectroscopy, plasma emission spectroscopy, spark or arc emission spectroscopy, UV visible spectroscopy, IR spectroscopy, Raman spectroscopy, NMR spectroscopy, photothermal spectroscopy, thermal infrared spectroscopy, and mass spectroscopy. It is called mass spectrometry. Now friend, fluorescence spectroscopy. Fluorescence spectroscopy uses higher energy photons to excite a sample, which will then emit lower energy photons, and this technique has become popular for its biochemical and medical applications. You can see the excitation source, excitation filter or monochromator, sample. You can also see the emission filter or monochromator and detector. Simplified fluorescence spectroscopy process. So friends, X-ray spectroscopy. X-rays of sufficient frequency interact with materials and excite the atom's content. Due to this excitation, auger effect is produced and some excitation radiation are absorbed or evolved if vice versa occurs. X-ray absorption and emission spectroscopy is used in chemistry and material science to determine the elemental composition and chemical bond. Very good and versatile technique but a little complex. It needs some scattering light detectors along with X-ray source. Overall, X-ray diffraction technique is one that is used most widely for bond length and angle measurements. Now friend, flame spectroscopy. Liquid solution sample are aspirated into a burner or nebulizer. Burner combinations dissolved, atomized, and sometimes excited to high energy electronic state. The use of flame during analysis require fuel and oxidants, typically in the form of gases. Common fuel gases used are acetylene or hydrogen. Common oxidant gases used are oxygens, air, or nitrous oxide. These methods are often capable of analyzing metallic elements in the ppm, billions, or possibly lower concentration ranges. Light detectors are needed to detect the light with the analysis information coming from the flame. Atomic absorption spectroscopy, atomic emission spectroscopy, atomic fluorescence spectroscopy. How would you differentiate in them? So my friend, spark or arc emission spectroscopy. It is used for the analysis of metallic elements in solid sample. For non-conductive materials, a sample is ground with graphite powder to make it conductive. In tradition arc spectroscopy method, since the conditions producing our arc emission typically are not controlled quantitatively, the analysis for the element is qualitative. Nowadays, the spark source with controlled discharge under argon atmosphere allow that this method can be considered eminently quantitative, and its use is widely expanded worldwide through the productions controlled laboratories of foundries and steel mills. UV visible spectroscopy. You can see it is basically involved the spectroscopy of photons and spectrophotometry. It uses light in the visible and adjacent near ultraviolet and near infrared ranges. UV visible spectroscopy routinely used in the quantitative determination of solution of transition metal ions and highly conjugated organic compounds. For the quantity measurement, Beer-Lambert's law is followed. The Beer-Lambert's law is useful for characterizing many compounds but does not hold a universal relationship for the concentration and absorption of all substances. And the second order polynomial relationship between the absorption and concentration is sometimes encountered for a large complex molecules such as organic dyes. So infrared spectroscopy. IR spectroscopy is the subset of spectroscopy that deals with the infrared region of electromagnetic spectrum. It covers a range of techniques, the most common being form absorption spectroscopy. As with all spectroscopic techniques, it can be used to identify compounds or investigate sample composition. Infrared spectroscopy offers the possibility to measure different types of interatomic bond vibrations at different frequencies. Especially in organic chemistry, the analysis of IR absorption spectra shows what type of bond are present in the sample. Infrared spectroscopy exploits the fact that molecules have a specific frequency at which they rotate or vibrate corresponding to discrete energy level. You can see the IR source, you see the sample, you see the reference, splitter, detectors, processor, and printer. So Raman Spectroscopy. Realize on inelastic scattering or Raman scattering of monochromatic light, usually from a laser in the visible near infrared or near ultraviolet range. The laser light interact with phonons or other excitation in the system, resulting in the energy of the laser photons being shifted up or down. The shift in energy gives information about the photons modes in the system. The spontaneous Raman scattering is typically very weak, and the results, the main difficulty of Raman spectroscopy is separating the weak inelastic scattering light from the intense Rayleigh light. scattering laser light. Raman spectrometer typically use holographic diffraction grating and multiple dispersion stage to achieve a high degree of laser ejection. So, nuclear magnetic resonance. Nuclear magnetic resonance spectroscopy analyzes the magnetic properties of certain atomic nuclei to determine different electronic local environment of hydrogen, carbon, and other atoms in organic compounds and other compounds. This is used to help determine the structure of the compound. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.